All right. So, very quickly, I know a few people weren't here, but very quickly, the reason I always put chi-square stuff at the end is because it's so different from the normal distribution. The normal distribution we use a lot. We use it all the damn time. So I want to get all the way through chapter 10 with normal, and then I can come back and do this chi-square. This is how you say this. All right, we had there's alternate ways you can say that. Let's see what reaction you get from me. Can somebody tell me what's the shape of this? What's different about the shape? I love it. Skewed to the right, or I like the visual. Yeah, so it's got a bit of a tail in that direction, right? And this is, again, this is kind of created by plotting sample variances down that you get using that formula we talked about. So here's how you get a chi-square value. Cool. Yes, sir.
Is it always skewed to the right, or is it skewed to the left?
It's always skewed to the right. And it has to do with how the sample standard deviations, how they approximate the population, variance, right? How the sample variance approximates it. They're all going to be clustered down here, but you could have extreme possibilities. You could have a sample where you pick nothing but the youngest and the oldest. And that's why there's always going to be a tail up that way. But it smooshes down here because there's a hard zero there. It can't go past there. So it's always going to be smooshed up against this wall a bit and free to go out that way a little bit. Cool. All right. So this then leads, very much like, I try to make this analogy, we have this z-score formula, so there are some similarities here, not with the pieces parts, but with the idea behind each. So the same way that I can kind of rearrange this and get this, which led to our confidence levels for means, confidence intervals for means, I can kind of play around with this and get to a confidence interval for variances, right? So this is kind of like what we did last time. So if I solve this to the variance, I get this. And we had this huge discussion about this is not going to be symmetric. And not even that, but 0 is not in the middle. So not only is it not symmetric like the normal, it doesn't have 0 in the middle. So confidence intervals for z-scores are always easy for normal distributions because if one side is negative 1.96, the other side must be positive 1.96. And that's why the formula is so nice and easy. You can write it really concisely. This dude, you can't. Because you're going to have one chi-square that I call chi-square small. And the book calls it chi-square left. And that always confuses the hell out of me. And chi-square big. But it's the same idea. If this was z, negative z and z, this would capture so much percent of the information. It's exactly the same idea. It's just that my distribution is moved over and not symmetric anymore, so it's a little bit harder. But once you see how the chart works, it's actually not harder, right? It's pretty easy to find those values, is my hope. So has everybody still got their chart that I gave them last time? Do I still have a chart? Oh, you need a chart? Ah, there we go. I knew I had them. Anybody else see a chi-square chart? All right, so we're going to look up a few values real quick, just to remind everybody how it works.
Do you have any more of those charts?
Yes.
Thank you.
Let's see if my timer can hold up for a while. Looking over your shoulder. All right. when you first look at this thing, it's just kind of like when we have the T-score chart. I'm sure a lot of you guys, I think some of you actually moaned so I could hear it, but at least the rest of you were doing so in your head. But that turned out to be pretty damn easy to use. In fact, we use it more often now, don't we, to get Z-scores too. So this guy, let me give you a situation. So if we had, yeah, just listen up. I'm going to keep you face that one. If we had n was, well, let's see what happens. 41, and I want a 98% confidence interval. So here's the next kind of level to get used to. We got the chart to figure out how to use, but before we can even start to use a chart, we have to understand what numbers to look at based on what situation we're in. So if I want the 98% confidence interval, what do I need to find out to be able to use this chart? Yeah, in fact, the chart's based on the area to the right. So if I'm trying to find, trying to make that sail, if I'm trying to find the 98% confidence interval, how much is to the right of this guy? 1%. Yeah, 0.01. And then how much is to the right of this guy? 0.99. So these are always going to add up to be 1. You know, one as a decimal. Cool. So now I know I'm going to look at 0.01 and 0.99 to find my two values. And I think, I forgot here, the two values that we're going to look up, I call them chi-square big and chi-square small. And of course I put the big one there because when I divide by big I get small, so it's going to be the smaller value, right? The lower part of my interval up to the larger part of my interval. Okay, cool. So this is a consequence of the fact that this is not symmetric and it's not centered at 0. But I really hope some of you guys can understand that it's the exact same idea as any confidence interval we've done. I still just want to catch that much information. It's just that the information is not symmetrically located around 0 anymore. Right? So in this situation, what's my degrees of freedom? 40. And I want to look at, like we said, I want to look at, one of them is going to be 0.01. It's going to be chi-square big, right? So if I follow that down to 40, what do you guys get? By that number I'm pointing at. 63.691?
Yep.
So that'll be this guy here. So that's chi-square big. Chi-square small, so named because it's smaller. It's going to be what? Where do I look to find him? 0.99, take a guess. So I look at 0.99. Go down to 40. 22.164. Cool. And then you would just plug and chug that in, right? So obviously, what have I not given you yet that you would need to do this? Sample standard deviation. So if you knew that, you would plug that in there. You plug those chi-square values you just got in there. You figure out the lower part of your interval and the upper part of your interval. Kick ass. In a way, it's kind of better that there's no plus or minus. You can't write this in that way. So it kind of forces you to realize it is a something up to something, right? You're not looking for your plus or minus keys in your calculator. All right, so how are we doing so far? So most of us were here last time. This is kind of a quick review. If you weren't here, that was probably not sufficient for a actual introduction to it. But, oh well, here we go. I'm going to give you this. I got this special one from me. So I want each of you to pick your own data. You'll see what I mean when you get these. But you can certainly work together.
Are you going to work with me?
If you want, sure.
Are you your best friend again?
Sure.
Yeah, you're your best friend. He's just a little
Little dude.